Today we're going to be talking about solving and graphing linear inequalities. So let's talk first about what an inequality is. It is a comparison other than equality, that is other than equals, of two or more quantities. Here are some examples. X is not equal to 3 is written as X equals with a slash through it, 3. X is less than 3 is written with the less than symbol, which you'll remember points toward the smaller number. X is greater than 3 is written with the greater than symbol. These three inequalities are called strict inequalities because x and 3 cannot be equal. There are inequalities that are not strict and that allow for the possibility for x to be equal to a number. For instance, x is less than or equal to 3, and x is greater than or equal to 3. When we graph inequalities on a number line, if it is a strict inequality, we'll place an open circle on the number. If it is not strict, we'll place a closed circle on the number to indicate that the number is also included in the graph. If x is not a number, we'll place an open circle on it and shade both left and right of the number to indicate that all other numbers are included. If x is less than a number, we'll shade to the left of that number. Greater than will shade to the right. Please be sure to use arrows on your graph to indicate that it continues beyond the limits of the number line. We'll also have to be very careful as we read our inequalities. 3 is greater than x is the same thing as saying x is less than 3. The second representation is probably the most convenient one for us when we're speaking about the inequalities. Let's graph some inequalities. In example 1a, a is less than or equal to 4. We'll place a closed circle on 4 and shade to the left. And I'll use my arrows to indicate that the graph continues to the left. M is greater than negative 3. Place an open circle on negative 3. Shade greater than, which would be to the right. X is not equal to 2. We'll place an open circle on 2, and we'll shade everywhere else on the number line that is not the number 2. U is greater than or equal to 0. Closed circle on 0. Shade to the right to indicate that U can be larger than 0. In E, this would be a convenient one for us to rewrite as K is less than or equal to negative 1. So we'll put a closed circle on negative 1 and shade to the left to indicate values that are less than negative 1. F should probably be rewritten as well, as W is greater than 3. So we'll place an open circle on 3 and shade to the right of 3. In example 2, we'll translate some statements into an inequality. A class has fewer than 15 students. So this class cannot have 15 students in it, so we know it's a strict inequality. In fact, the class has to have less than 15 students. So I might say S, which could stand for the number of students, is less than 15. In B, Greg is at least 6 feet tall. Now it has that word at least, which kind of sounds like less than, but if you think about what this statement means, it means that Greg can be 6 feet tall, but Greg can also be taller than 6 feet. So Greg's height, which I'll call h, is greater than or equal to 6 feet. In C, a denominator may not be 0. This is not a less than or a greater than statement. It's a not equal to statement. So I'll use the letter D for denominator and write equals with a slash through it. D may not equal 0. You may have no more than 3 potato chips. I'll use the letter C to stand for the number of potato chips. And if you may have no more than 3 potato chips, you may have less than 3 potato chips or you may have exactly 3 potato chips. So the number of chips is less than or equal to 3. When we're solving a linear inequality, we are going to do it in the same way that we solve equations, that is, by isolating the variable on one side of the inequality, by adding, subtracting, multiplying, or dividing on both sides of the inequality. Let's cross that out and write the word inequality there. If you multiply or divide by a negative number, however, we have to change less thans to greater than or greater thans to less than. Here's why. If x is greater than 5, what numbers could satisfy that inequality? X could be 6 or 7 or 8, etc. If I take that inequality and I multiply it by -2 on both sides, that would give me -2x on one side of the inequality and -10 on the other side of the inequality. Think about the numbers 6, 7, and 8 that we just talked about that satisfied the original inequality. If I take 6 and I multiply it by -2, I get -12, which is less than -10 or to the left of -10 on the number line. So when we multiply or divide by a negative, we change signs to opposite signs, which changes the sense of the inequality from greater than to less than, or vice versa. Okay, in example 3, we are solving each inequality. So in 3a, we'll add 1 to both sides of the inequality to get 2x is less than 10, and then we'll divide both sides of the inequality by 2 to get x is less than 5. We did not change the direction of the inequality because when we divided by a positive number. That's the solution to the inequality, and the graph of that solution is a number line on which the number 5 is indicated with an open circle, and since x is less than that number, we'll shade to the left. In B, -3x plus 2 is greater than 14. We'll subtract 2 from both sides to get -3x is greater than 12. And then next, we'll divide by -3. I'm going to put a note here that we just divided by a negative number. And so that's going to change the sense of the inequality from greater than to less than. So if we divide our left side by -3, we get x by itself. If we divide the right side by -3, we get -4. So that is the solution to the inequality. X is less than -4, and its number line representation or graph is the number -4 graphed with an open circle and then shade to the left of -4. In C, we may want to clear our fractions before we do anything. So we'll multiply through on both sides by the LCD 6. That's a positive number, so we are not changing the sense of the inequality. 6 times a half x is 3x. 6 times 2/3 is 4. And 7/6 times 6 is 7. Adding 4 to both sides, we get 3x is less than 11. And then dividing by 3 on both sides, x is less than or equal to 11/3. That is the solution to the inequality, and the graph is a number line where 11/3 is indicated with a closed circle, And since the inequality is less than, we're going to graph to the left. In our next inequality, we can clear the fraction from both sides, or we can clear the fraction by multiplying both sides by 3. That will undo our division on the left side, and the result will be 8 minus u is greater than 6. Subtracting 8 from both sides, we'll get negative u is greater than negative 2. And then I'll write myself a note again because I'm just about to divide by a negative. We divide both sides by negative 1. We get u is less than positive 2. Again, the sense of the inequality changed because we divided by a negative. And so that graph is the number 2 with an open circle. And since the inequality is less than, we'll graph to the right of 2. In E, we have some parentheses to distribute multiplication into. So we get 6 minus 4x is greater than 10 minus 4x. Adding 4x to both sides, we'll get 6 is greater than 10. That statement doesn't have a variable in it, and it's never true. If it's never true, that indicates that there is no solution. And if we were to graph that on the number line, we would just have a blank number line. Nothing would be shaded. In F, we again have some parentheses that we have to take care of. We're going to take the opposite of everything in that parentheses, distribute times -1 into the parentheses. And then on the right side, we have to be careful. Just because there's a parentheses doesn't mean that we're multiplying. This is 2y plus the parentheses. So 2y plus 1 plus y. And now we can combine some like terms. On the left, we have 3y minus 1 less than. On the right, we have 3y plus 1. Let's subtract 3y off from both sides. We get -1 is less than +1. This statement is always true. So this is what we call an identity, which has a solution of all real numbers. If we were to graph the solution on a number line, we would simply shade all of the numbers on the number line. Okay, let's work a few word problems. We're going to write and solve an inequality to solve the problem in example 4a. Karen earns 2 test grades of 85 and 70. What is the lowest grade she can earn on the next test to ensure that her average is at least an 88? So x is equal to Karen's next test score and what we were told is that we would like for her average to be at least an 88. At least means it could be equal to 88, but it also could be greater than 88. So we'll use greater than or equal to. Now remember how you compute an average. In order to compute an average, you'll take the 3 test grades, 85, 70, and x, and add them together, and then divide by the number of test grades. In order to solve this inequality, we can multiply both sides by 3. If we multiply both sides by 3, we get 85 plus 70 plus x is greater than or equal to 88 times 3, which is 263, no, it's 264, excuse me. And then we can subtract off 85 and 70. 85 and 70 are 155. So I'm going to subtract off 155 from both sides of this equation to get x is greater than or equal to, and that would give us that would give us 109. So there had better be a bonus question on Karen's next test. So 109 is what she needs. In B, a rectangular dog pen is fenced off so that it's 5 feet longer than it is wide. Let's draw a picture. The width can be called x, and the length can be called x plus 5. No more than 70 feet of fencing may be used, so we have to use fencing on all 4 sides. That is to say, we're going to use fencing around the perimeter of this rectangle. So the perimeter should be no more than 70 feet or less than or equal to 70 feet. So 2 times x plus 2 times x plus 5 is less than or equal to 70. That's going to give us 2x plus 2x plus 10 on the left side, or 4x plus 10 is less than or equal to 70. 4x is less than or equal to 60 if we subtract 10 from both sides. X is less than or equal to 15 if we divide by 4. So what are the pen's maximum dimensions? Its width would be 15 feet by 20 feet maximally. That is to say that the pen could be smaller. All right, in example 5, we're just writing an inequality to represent each situation. Robert earns $500 per week, plus 5% of all sales he makes. What we're letting x equal is the weekly dollar amount of sales Robert needs to earn at least $700 per week. So we would like Robert's earnings to be at least, that is to say, greater than or equal to $700 per week. We know that Robert's earnings are $500 plus 5%, which is 0.05 of, which means times, all the sales that he makes, which is represented by x. So our inequality is 500 plus 0.05x is greater than or equal to 700. Do not solve the inequality, so I'm just going to circle the inequality that I wrote. In B, 40 feet of fencing are available to enclose a rectangle. Let x be the width of the enclosure so that the area is no more than 75 square feet. So what we know is that there are 40 feet of fencing available. And again, fencing around a rectangle is its perimeter. So if x is the width of the enclosure, then the perimeter, 2x plus 2 times the length, has to equal 40. We don't have an expression for the length, but we can certainly figure one out. We can subtract 2x off from both sides, and that will give us 2 times the length is equal to 40 minus 2x. And then we can divide by 2. So L is 40 minus 2x over 2. And 2 can be factored out from the numerator of that fraction. And then you can grab your handy dandy red cancellation pen. And the length of the enclosure is 20 minus x. What we were told in the problem is that the area should be no more than 75 square feet. So that means that our area should be less than or equal to 75 square feet. Area, as you know, is length times width. So our length is 20 minus x, and our width is x. So the area will be x times 20 minus x, and that has to be less than or equal to 75. Again, we're not solving it, we're just writing the inequality. And that's it for today.